Welcome back to Applied Algebra. In the last video we multiplied monomials or single terms. We also took them to a power. In this section we're going to move on to multiplication of polynomials. So instead of doing a single term and a single term, now we might do a single term with a binomial or a single term with a trinomial or larger ones as shown in some of these examples. This 4x squared minus 2x plus 6, we have a trinomial being multiplied by x plus 3, which is a binomial. The first method that you're seeing on your screen here is called the stack method. It allows you to use the algorithm that you're used to in the past maybe of multiplication. It stacks the like terms, which allows you to put them together nicely. Another method that you might use is the distributive property. That's what's happening here with the x squared plus 5, which is also a binomial, being multiplied by x squared minus 11x plus 6, which is a trinomial. X squared is being distributed and multiplied by each of the terms of the trinomial, and then 5 is being distributed and multiplied by each term of the trinomial. In that case, the terms tend to be written out horizontally, and so you have to recognize the like terms and combine them. This last method shown on this page is the box method, where it's an organizational tool. It helps you multiply them. It's essentially doing the distributive method but in a box sense. Your like terms will always be in this diagonal as it's circled here in the red that you can then combine. So I will work through each example for you. You can then make your decision. If you need more examples of a certain method, let me know and I'll get those to you. So this first one, I'm going to go ahead and do example 1 just using the distributive property. With it being a monomial times a trinomial, the distributive property just might be the easiest. So we're going to do 4a times a cubed, 4a times negative 3a squared, 4a times 2a. So we're going to use the properties that we used in the last section where we are adding the exponents when we distribute if they are the like variables. We're going to do 4 times 1, which is 4. I have a to the first, a to the third, 1 plus 3 is a to the fourth. 4 times negative 3 is negative 12. A to the first plus a to the second is a to the third. Now when I'm saying plus, I'm adding exponents, not adding the actual terms. 4 times 2 is 8. A to the first and a to the first, so 1 plus 1 gives me a to the second. I then have to make sure that I look at these terms and see if there are any like terms. I have a to the fourth, a to the third, a to the second. They're all different exponents, so these are not like terms. This is my final answer. Looking at example 2, I'll go ahead and do the stack method. Oh, I'm doing another monomial. So never mind, we'll just go ahead and do the distributive property. Negative 6 times 4 is negative 24. A to the fourth, a to the third. 4 plus 3 is a to the seventh. There are no b's in this second term, so the b to the second just carries on. Negative 6 times the negative 5 is a positive 30. A to the fourth, a to the first. 4 plus 1 is a to the fifth. B to the second, b to the first. 2 plus 1 gives us 3. Negative 6 times 6, negative 36. A to the fourth. There are no a's in this one, so it just stays a to the fourth. B to the second, b to the fourth. 2 plus 4 gives me 6. As I'm looking for these to see if there are any like terms, not only do they have to both have a and b, they have to be exactly the same exponent. There are no other a to the sevenths, there's no other a to the fifths. These are all different terms, so that is my final answer. 6x minus 4 times 3x plus 5. I'll go ahead and use the stack method. So I have 6x minus 4 stacked on top of 3x plus 5. We are multiplying. What I'm doing here is I'm going to do 5 times 4, or sorry, 5 times negative 4, which is a negative 20, Now I'm going to do 5 times 6x, which is 30x. Now that is essentially the distributive property, it's just more of an organizational tool on how it is. Now just like when we're doing the algorithm for multiplication with numbers, we're going to slide over, so our next answer is going to come just below the 3x when I write down my answer. I'm going to go ahead and change colors. I'm going to go 3x times negative 4, bring it straight down, negative 12x. 3x times 6x, 3 times 6 is 18. X to the first, 1 plus 1 is 2. So in this method, my stacked terms are the same. So the 30x, which is a positive, and the negative 12x, I can combine to get 18x. There's no other like terms, so I just bring down the negative 20, and I just bring down the 18x squared. I'm going to put a plus here because my 18 was positive. So that is what happens if you do the stacked method. I'm going to go ahead and show what that would look like if I were to do the box method. Creating just boxes. 6x minus 4. Now it does not matter which one goes where, so I'm just going to go ahead and put the 6x and the negative 4 here. 3x plus 5. The example that I showed you up above has the terms on the bottom. I have seen this done with the terms be also on the top. That's a personal preference. So to create this box right here, that is a combination of the 6x and the 3x. So 6 times 3 is 18. X to the first is x to the second. To create this box, that's the 6x and the 5, because those are the two that would make this. 6x times 5 is 30x. This box is created by the negative 4 and the 3x. Negative 4 times 3 is negative 12. There's no x's here, so this x just tags along. I need a different color. This box here, I just lost my color. This box here is created by the negative 4 and the 5. Negative 4 times 5 is negative 20. As you're looking at this, the nice thing is that this diagonal is always your like terms. 30x and negative 12x is 18x, just like it was over here. Doesn't matter what method you use, you should get the same answer. There's no other like terms, so I'm just going to bring down the 18x squared. No other like terms with the negative 20, so I just bring that down. Exact same answer, just different method organizationally. I'm going to go ahead and erase just that because I can't see that negative 5. So in this one I'll go ahead and do the distributive property. So I'm going to go x times x squared, 1 plus 2 makes 3. X times 3x, 1 plus 1 makes 2. X times negative 5 would be negative 5x. So I've distributed this x and I've multiplied it by each of the terms in the next one. Now if I go ahead and distribute the 4, I have to multiply it by each of the terms. 4 times x squared is 4x squared. You could stack these as you wanted to if you wanted to combine methods to keep your like terms together, or you can go ahead and just go out horizontally. 4 times 3x is 12x. 4 times negative 5 is negative 20. Now I'm going to go ahead and look for like terms. There are no other terms with the x cubed. I have 3x squared and 4x squared, makes a total of 7x squared. I have negative 5x plus 12x, that gives me 7x, and then negative 20 is all by itself. So we have the stacked method, we have the box method, and the distributive method. So you'll want to pick one method and try that one a few times, see if you like it and it's working for you. If you're getting stuck, go ahead and try a different method. If you do need more examples of a specific method, please let me know and I'll get that uploaded for you. Thank you and have a good day.